And hello. Today we'll be looking at volume. So this is the final lesson in the perimeter, area and volume chapter. So you should have already looked at perimeter and area before this lesson. So what is volume? Volume is a three-dimensional measurement of how much space an object takes up. So measurement of how much space an object takes up. Well, what do I mean by that? In real life, you have objects all over the place. You yourself are an object, and we're measuring how much space in the real world do you actually take up. Now, we live in 3 dimensions in the real world, and what do I mean by that? Well, going back to my 3 examples that I always use, if we're looking at height, that's just the length. That's just only up and down. If we're looking at the area of a flat rectangle or like a sheet of paper, that would only be 2-dimensional because we're only measuring, okay, well, how much width it has and how much length it has and how much space, that kind of 2D shape. It's flat, completely flat. Anything in the real world is actually 3D. So this water container, if we were to fill it up with water, we'd say, okay, how much space does that take up in the real world? So this would be a 3-dimensional shape, or a 3-dimensional object, I should say. So what is the unit of volume? Well, I really like this graphic, and it's something to kind of bear in mind. So 1 dimension, if we all lived in 1 dimension, it would be like living on a line. We could only go forwards and backwards. Couldn't go anywhere else. If we lived in 2D, imagine we're a very, very tiny ant that lives on a sheet of paper. We could only go up or down. We can't on this. So we're looking down on the sheet of paper now. This little ant could only go up. It could only go down. Can't jump up off the sheet. 3 dimensions is just the real world. So we can move in any direction. We can move up and down, left or right, forward and backward. So what are the units? Well, remember, 1 dimension, let's say centimeters or meters or kilometers. 2 dimensions, we square it, because remember we're counting all these little squares in the actual area. So this would be the area of a sheet. Well, that would be centimeters squared. And you'll notice, see the way it says 2, so it's to the power of 2, and there's 2 dimensions. So thinking about it, if we're counting squares, little squares in 2D, what about 3D? And what do you think the unit would be? Well, it would be cubed, centimeters cubed, and we'll see why. But a nice way to remember it, 1 dimension, this is actually to the power of 1 if you think about it. We just don't bother writing it. So this is centimeters. 2 dimensions, so area is squared. 3 dimensions, centimeters cubed. And we don't really worry about 4 dimensions, that's for college. So this is really important. Remember your units. They do take marks off if you get the wrong unit. If you're measuring, let's say, area, make sure you get your squared. If your volume, cubed. So why is it cubed? Well, remember we were looking at area and we were counting all those little squares and it was centimeters squares. Well, now we've upgraded to 3D and we're counting how many of these little cubes. So we're looking at centimeter cubes. So what is a cube? Well, it's just a square, but it's become 3D. So we have a square on all these sides of the shape. So how many faces does it have? This is from primary school. It has 1, 2, 3, 4, 5, 6. 6 faces, and they're all squares. So that's 1 centimeter length, 1 centimeter length, 1 centimeter length. They're all sides 1 centimeter. So the unit of this, or the volume of this cube, is 1 centimeter cubed. So let's say we had a bigger shape like this. What we're actually doing is just counting how many of these cubes are in the whole shape. So this is what we're actually counting. We're just counting all these little cubes. We divide it up into all these cubes, and then we say, okay, how many cubes are in the whole thing? So this is really important. Just like the squares from area, you need to understand why it's cubed and what we're actually counting when we're looking for the volume of a shape. So, volume of cuboids then. If I wanted to find the volume of this, well, all I gotta do is count the cubes. So it's 1, 2, 3, 4, 5, 6. So that's kind of on one kind of slice. Yeah. How many slices are there then? Well, there's 1, 2, 3, 4, 5. So there's 6 on one kind of slice. If I were to cut it here, so there's 6 cubes, and then there's 5 slices. So how many cubes are there altogether? Well, it would be 6 by 5. How much is that? 5, 10, 15, 20, 25, 30. So there's 30 cubes altogether. So the volume of this would be 30. Now we're working centimeters, so it's centimeters cubed. Now, how did I get that? Well, what I actually did was I said, okay, I said there's 2 rows. There's 3 in a row. So that's 2 by 3. That's where I got my 6 on a slice, yeah? And then there's 5 slices. So I said, okay, well, it's 6 by 5. But what I actually just did there was 2 multiplied by 3 multiplied by 5. Another way you could think about it, okay, how many are in this kind of bottom, if I cut it straight in half, cut it horizontally in half. Well, how many are on the bottom row? Well, it would be 3 by 5. And there's 2 slices. Yeah, this is the bottom slice, and then there's this top slice. So that would be 3 by 5 by 2. Same logic, doesn't matter which way I multiply them together, I'm going to get how many cubes are here altogether. So, where does this matter? Well, the area for the volume of a cuboid, so this is what we call a cuboid. It's not exactly a cube, but it's kind of like a rectangle 3D, is the length by the width by the height. So if I know the height, if I know a width and I know a length, I can find how many cubes are in it altogether. So, looking at this example, how would we find how many centimeters cubed are in this object? Well, I know there's a width here, there's a length here, and then I have a height. So I can just multiply them all together. That's what I'm going to do. And I can get the volume. So I have 15 times 9, or 15 times 10 times 9. Again, it doesn't really matter what you call the length, what you call the width, what you call the height. You can kind of multiply, if I change this 10 and 15 around, if I put the 10 before the 15 and then I put the 9 over here, or whatever, if I change these around, doesn't matter. 3 times 2 is the exact same thing as 2 times 3. So, if I multiply 15 by 10 by 9, that's 1,350 centimeters cubed. So that's how many little centimeters cubed are in this whole cuboid. Okay, here's some recap questions for you, so you can have a go at them. So, find the volume of the cube. So, this is a cube, and it's told me one side is length 5 centimeters. Now, I'm only given one side, so how am I going to find the length by the width by height and all that? Well, it's a cube, so I know the length of all the sides if I know one of the sides. Because remember, a cube, all the sides are the same. So this is 5 centimeters, this is 5 centimeters, this is 5 centimeters. All the lines on this are 5 centimeters. So what's the length by the width by the height? Well, it's just 5 by 5 by 5, which is 125 centimeters cubed. Okay, find the length of the side. So it's told me this is 8 centimeters. It told me this was 3 centimeters. Then it told me the whole volume was 120 centimeters. So the volume is length by width by height, whatever you want to call it. So that's A by 8 by 3. So that's A by 8 by 3. Going back to your algebra, A by 8 by 3, I can multiply the 8 and the 3. So that's 24A, because remember, we can just write 24A is the same thing as 24 multiplied by A. It's equal to the volume, which is 120. So 120 is equal to 24 multiplied by A. How am I going to find what A is? Well, I can divide both sides by 24, or remember from algebra, if I bring the 24 over, what happens? It's doing the opposite operation, so it's going to divide. Or to think about it, what do I multiply 24 by to get 120? Well, the answer is 5. So 5 centimeters is the length of A.